All right, great. So which screen are you seeing? My PowerPoint or the first one?
Yep, we can see the PowerPoint.
The PowerPoint, perfect. You got the right one. Thank you. Hey, hello everyone. Good morning, good evening, whatever you are. I am here in sunny California, north of San Francisco. And thank you guys for having me here with you today, presenting on this topic I put together a couple months ago for my local group here in Sacramento and also down there in San Francisco. So again, in this slide, my name is Armando Lacerda, and I work for DesignMind. DesignMind is a all data related project consulting company down in San Francisco. We're headquartered in San Francisco. We have an office down in Irvine. And in my particular role as a BI and Azure architect, I implement projects around data warehousing in Azure using multiple servers, Azure Data Factory, and pretty much all of our front ends are done in Power BI, and sometimes even the data warehouse is done in Power BI too. So I've been working on the data field for over 30 years. I started with Oracle 7. Actually, I started way before that with DBase 3 down in CPM systems. Most of you may not have ever heard about this thing. But the SQL Server arena, I started with SQL Server 6.5. And Josh, while you were presenting, I was doing like traveling the memory lane here. The first pass was down in 1999. So I do believe it's the 20th pass summit. Yeah. So it's definitely this 20 years because the first one was 1999. So next year is going to be the 21st, I think. So I was there on the very first one in Chicago, kind of a founding member. I stayed away for a few years, involved in other projects. But again, hey, we are here in Azure and Azure SQL Database. So let me tell a little bit about the story of this presentation. Like Josh mentioned, at PAS, in our user groups, we always open the doors for people in the group to present on their experience. And this particular one here is about that. It's presenting on an experience I had with a friend of mine down in Brazil. By the way, I'm from Brazil. We moved here to California, but I'm from Brazil. And this friend of mine works with IoT systems. And we presented together at Ignite 2017 last year on the project related to this one here. And the background of this is he wants to use Power BI at the front end. He does IoT, like I said. IoT was not my thing back then, but he got the fever on me. Now I love IoT. I have a lot of IoT experiments here running my workbench at my own home office. But back then he was like, Armando, we need to work on a dashboard to show how the sensors are going in the fabric and how the things are going there on the production line. And, I'm not able to get Power BI to work on this thing. So how can I get insights on massive data ingestions? And I went to the Power BI documentation for that. And the documentation says Power BI can take a lot. But when I saw their numbers on their projects and how much data was coming in, I say, oh boy, we have to come up with some other implementation. So what we've done is we created a collection of alternatives, and I'm going to open this collection here for the next 45 minutes with you guys on how to get that massive amount of data using Azure resources, including Azure SQL Database, and ending up on the front end in Power BI with very little code. And that's one of the things I love about the cloud. We really don't have to code that much. There are, of course, places where we want to have the code, but we don't have really to code that much to get the things going. So this slide here, where's my cursor here? So this slide here is about insights. And the formula we used was Azure Functions. This square thing here is just to decorate. But the Azure Functions, IoT Hub, and SQL Server, Azure SQL Database, the PaaS offering, and Power BI. like I said, this presentation was created a few months ago, so there are some alternatives already there in the cloud, and I'm gonna talk about that. I'm gonna have a presentation. It's not ready for today because I ran out of the credits for my Azure thing to present on resources, but I do have some code here to share with you. So that's the agenda. We're going to start on the Power BI side and understand the limits, why Power BI cannot just get the data coming from the IoT stream. And then we see the answer for that, which is the LAMBDA architecture. So, and then see how that can be implemented in Azure SQL Server and Cosmos DB and some other options that are not here on this slide. So let's go for it. If you're familiar with, this virtual group here is the cloud implementation, right? It's all about Azure SQL database, I believe. But at the front end, you need to have something at the front end to show data. And Power BI has been a very popular option for many companies and many markets to present data, to create dashboards and reports. Just yesterday, I was presenting this to a big retailer here in San Francisco, and looking how to create dashboards on the real estate management side. So Power BI applies in a bunch of, I'm working right now on a project also in Power BI, deploying a data warehouse over 300 gigabytes of data. And Power BI is an amazing tool. We can do a lot with it. But Power BI has its particular ways to work. One of the things to understand about Power BI is Power BI is the front end. And at the back end, what we actually have here all the time in Power BI is some sort of a Power analysis service, SQL Server analysis service. So Power BI always works on top of SQL Server. So if I go here and open, on top of analysis service. So if I open Power BI here now, it's spinning up here just quick. I'll show you here. Brand new Power BI session here. Just started it. And once it's up and running, it just opened another screen here, but let me open the task manager here for you guys to see. When you start up Power BI, what you see, and just have to find it here. Stay quiet. There we go. Power BI desktop. And what you can see down here is SQL Server Analysis Services spinned up by Power BI itself. This is a process within Power BI to take care of the data that will be presented through the reports in Power BI. So Power BI is based on a SQL Server Analysis Service, and therefore Azure Analysis Service as well. We have the option to work in Power BI by importing the data into Power BI. So that's one way of bringing data into Power BI. But there are limits to this. This analysis service that's inside Power BI is like what Microsoft has done with SQL Server. There is this Express edition of SQL Server. So this analysis service that runs inside Power BI is kind of an expression edition kind of idea of analysis service for Power BI. So like in terms of data, you cannot have more than 1 gigabyte of compressed data in analysis service in the cloud. In Power BI in the cloud when you upload data in. And the recommended way to get data to Power BI is always to import, to get the data into the analysis service storage and create the columnar elements in there, the relational model, and work it from there. It works great, but for real-time insights on data coming from IoT streams, which is the case for this presentation here, it doesn't work, because there is a limit on how many times you can refresh the data. So if I want to have real-time presentation or near real-time dashboards on the data, the Pro, which is the most common licensing for Power BI, would not suffice because I can only refresh the data 8 times a day. If I need to refresh more than that, there is an option, still working on the import in Power BI, which is 48 times a day. And it was funny because in some presentations I have seen some people from the product team from Microsoft presenting on this. 48 times a day is like 30 minutes. Every 30 minutes you can refresh the data. And some people from the product team and some other clients, they consider this near real time. Now for my friend's project, his name is George. For George, down there in Brazil with this IoT dashboard he wants to create, that's really, not near real time. 30 minutes gap, it's too too long. So that doesn't work for this kind of project when you have a near real time data being presented. So your next option in the traditional Power BI deployment is to do direct query. So in direct query, what actually happens is Power BI, instead of importing the data into the analysis service column of storage, what Power BI does is, it depends on the data source. So with the data source that do support direct query, it generates a query and sends the query back to the data source every time someone comes and browses the report looking for data. So that kind of brings near real-time information, but makes the system very, very slow, because it has to go back all the time to collect the data. And whatever system is behind the scenes, this is more likely not a data warehouse system, it's a relational database, so you have to go through concurrency, you have to go through isolation, and you press either memory or disk, or you queue up queries. So that also doesn't work well for real-time dashboards. What many people are not aware of in Power BI is the ability to create what Power BI calls a stream data set. The stream data set does not rely on analysis service. It does not import data into Power BI. It's actually backed by Azure SQL database, although you can't see it, you cannot connect to it, but it's actually backed by Azure SQL database inside Power BI. And the idea is Power BI opens up an API in the cloud, and through that API, you can push data. That's the idea. You can push or stream data into the data set. And you can do this with minimal to no code. You can do this even through regular HTML pushes, not just putting the data in the body of the message, and Power BI REST API endpoint can take care of that. And that's what I'm going to demonstrate to you. Before I get that to the demonstration, it's also important to keep in mind that if you're really going to go with more enriched data into Power BI, there is another option, which is using the actual Power BI API to make data pushes to regular data sets in Power BI, but that requires a lot of code. And if any of you have been to Microsoft Ignite this year, you register for the conference, it show up in there. If you want to try that code in C#, right, to push data into Power BI, not using the streaming, which they want to demonstrate here, you can go to My Ignite and go to look into hands-on labs. They do have that lab in there. I have people down there at Ignite doing that lab. We had hundreds of people there doing that lab. It was kind of cool. So with that said, let me get here to Power BI and do this first demo, right? I think it's the time for the first demo. Let me make sure. Yeah, that's demo. Still have the timing right in my mind. So what we do here is, actually it's not here in Power BI Desktop. That would be in Power BI Service. So let me get a browser here just quick. And let's connect to Power BI. PowerBI.com. I'm going to make these letters here a little bigger. Just make sure you guys can see it well and follow along. Let's sign in. I have Master Yoda helping us out here today. So let's do, I think, the password here is, I have a problem because I have so many demonstrations and accounts. There we go, got it first try. Nice. And so there you are. I got in Power BI Service, not in desktop, because the stream data set is something on the cloud. It's a cloud service from Microsoft in Power BI. And what we do here, we work with some workspace. Let's go to the Galaxy workspace. And on the dashboard, what I want to do here is I want to create a new dashboard to show incoming data, but it's going to be based on And let me know if the zooming here is working well. Let me zoom it. And I have not started yet. So hope this zoom here will show well on the screen. Oh boy, it's not going there. Sorry. So this is the option here, right? Streaming data sets. Like I said, the other ones are for regular data sets, the import and direct query. But this one here means I want to create a new dashboard in Power BI service with that data coming from API pushes. So, there are other options in here that do a mix and they can store data for a little longer. But for today, the API call will help us in the way we need. So the dataset name here, when you do this, the idea here is like you kind of create a table, a small table for the dataset. And so let's give it a name like sales, for instance. And these will be the columns of my dataset. It's funny, the autofill is giving my name to this thing. It's kind of funny. So let's say here this is because this is a dashboard. It's not a model with multiple tables. It's just a dashboard. So only one table is what we need in here. So let's call this here. Let's say product. The product that was sold, and that would be a text if I want to show the product name. This one here will be the store where it was sold, and this is also going to be a text. And let's say I would have here, the department. I'm not going to make this big that big, and this is the sales amount, and that is going to be my measure. And date is always good, right? Date and time. So let's get there for the timestamp. So, the point here is I have a sensor going out there, and this one here is like let's say the register, what the sales are being placed, and I'm gonna get that information coming here, and I'm gonna present the information every time a new sale comes in. So I'm gonna keep like a total, or perhaps just the last sale amount that came up through the pipe. So I got this guy there. If I want to keep some historical data, there is some a buffer, but this is not a replacement for any kind of database. This is just for the dashboard to work, and that's where the SQL Server behind the scenes comes in. So we create this thing, and here's the endpoint where applications can push data through. And this is how the payload looks like. It's just a JSON document, right? That's supposed to come through. And here's some examples about how to push this through HTTP protocol using CURL or PowerShell. So let's get here to the PowerShell one just to see this thing popping, right? So copy this guy here and go into PowerShell ISE. It's coming up. It came up on the other screen. So let me get this guy here and get a new file, put the code there, make the code a little bigger. And, this for you guys to have a sense of how easy it is to implement this. I think there is a word wrap here somewhere. Edit. Can't see the word wrap option anywhere. Yeah, somewhere over there. But just going through the code just quick. So that's the endpoint, what the hits on Power BI service. Just send the data through and the hash key in there. So someone has to have the hash key. It's your security people, they kind of freak out about that because it's authenticating the application of the user. So they kind of freak out a little bit about this. But it's kind of semi-secured channel, right? You got to have the hash key if you want to send data to your dashboards. And again, this is the payload in JSON format, and this is just one PowerShell command-let call to send the payload to the endpoint. So let's go ahead. Once my data set is created, let's go ahead and create a tile in my data set based on the streaming data set. And what is it? Oops, sorry, cancel. Come on, Give me a title. I just need my title. Dashboards. Create the dashboards. Create my dashboard, and my dashboard is demo one. There we go. So there's my dashboard. Let's add a title. There we go. And here I can choose data from regular data sources inside Power BI. And once again, these are the import and direct query. My other options you get from streaming that will come from other cloud services, for instance, which you're going to get there after this demo. In this case here, it comes from my sales data set, which is my endpoint, where the streaming will come in. And I'm going to add, not add, cancel. Armando, click it correctly. Don't get lost. There we go. From this guy here, next. Thank you. And then I can choose which kind of visual I want to show in there. So let's say I want to see the last sale that came in, and I may want to have a line chart with the count or something of the sales coming in. Oh, sorry. So card first. And the value I want to show is whatever is numeric. So it shows the numbers coming in as they come in. So that will be one. And the other one, let's call this one here, last sales record. And got this guy there. So here's my tile. And the next tile here, let's do it for, again, string data set, and sales, and next. Let's put here like a line chart with the information coming in. So my axis here would be based on the date as the data comes in. This one here could be, by store. I think store would be a good option in here, and the value to show is whatever sales is coming. And time to display, so for how long the chart will keep data showing up in there. Let's say the last minute of information. So create this too. Sales over time, and apply. And no data is coming yet because I don't have any code set anything there. But if I go back here to my PowerShell, I'm sending this value here. Let's say, let's put there 150 sale. And when, on the payload. So when I push this script, there we go. Got 150 showing up there right away, real time. And I got on that particular store, I got 150 in the timeline in there. If I keep pushing this, let's see, this one now is 200. Whoops. This one now here is 200. And I run this guy again. So 200 is over there. Well, the line is not coming, but should have presented here. Change this to 200. Sometimes you get a little lag there. And I think there is always an if, like I did my store. So San Francisco. Like if I'm presenting, you fail the thing. Sometimes it does happen. Yeah, see this style here, for some reason, is not refreshing. And when you start doing this, there is some warming up time that needs to get over at the back end in Power BI. So some of the tiles, right after you republish or refresh the layout of your dashboard, it takes a little while. It may take up to 5 minutes to get this dashboard fully functional. But in any case, we see the real-time data information coming here with latest of my streaming. So that's how we can get, one of the ways, one of the 2 or 3 possible ways you can get real-time dashboard show up in Power BI at the end. So I showed that to my friend, and he was like, great, we can get real-time, I see that. But there are limits to this, because sometimes it just freezes. And why does it freeze? Why the service stops? So when you get to the documentation, these are the upper limits of that kind of data streaming going into Power BI. it says here, look, a million rows. I can have up to 1 million rows per hour in that data set. That sounds like a lot, but in a regular IoT implementation, this can be achieved like in seconds. And so therefore, we cannot connect Power BI straight to a huge stream pipeline of data with massive information coming through. But the best option to get data real time, like when the data comes in shown on a dashboard, is by using these live streams. So we need to implement something in between the stream sources and Power BI, and that thing in between is the LAMBDA architecture. This is some other upper limits in Power BI, so it's there on the slide deck. I'm going to send to the group so you guys can get that later. But what we need is a LAMBDA architecture. Any questions so far on the Power BI support for this? Any questions you guys have on Power BI before we switch to the other cloud aspects of this implementation?
So far, there's no questions on this specifically, but there is one on an SSRS data source. And I'll ask that one at the end. Okay.
So moving on, what we need to do to support that the massive amount of data going into Power BI through the streaming channel is implement the LAMBDA architecture. So the LAMBDA architecture, before I start going to the illustration here, let me go here just quick on LAMBDA architecture book. Should be one of the first ones to show. This guy, yeah. This is the book about, one of the first books about big data and LAMBDA architecture implementation. Of course, I resourced out to this book here. And the funny thing about this book is it's fully based on Java technology and open sources. So the guy goes through implementing a LAMBDA architecture on open source platform, which is, it's great, it's kind of cool. But I'm a Microsoft guy, all Microsoft shop. So I had to work through the ideas in this book and start implementing the same idea, which very popular among big data implementations, but using cloud technologies. And on all fairness, to be true to the book and for you guys not to get surprised, one of the things of the LAMBDA architecture is we should avoid what they call code-based plurality. To get too many programming environments which are not or they do not use the same language or code base or even platform. In the book, the author there, he goes really like this. So, don't use SQL databases for LAMBDA architecture, not just because they don't perform, but because you have to deal with multiple programming languages. So you're going to do, in their case, like Java, and then you're going to do T-SQL, in the SQL Server case, and then you're going to do perhaps something else at the presentation layer. So you don't want to keep switching between languages, which kind of makes sense. When I read through the thing, I say, you're kind of too much of a purist guy, but it makes sense. Sometimes it creates a lot of complexities we would like to avoid. So if you're working with this and you have developers working for you, you may want to take a look on the entity framework that may help implementing queries using a regular C# language instead of multiple languages. In my case, I didn't go there. I did break that rule from the LAMBDA philosophy or the overall idea, and I used multiple languages in implementation. But in case you want to see the original idea, this is the book you guys should be looking for. They have it on Safari Books. I'm a Safari Book subscriber. I got all the books there on my subscription. In any case, so how does the LAMBDA architecture works? The way it works is you have your data sources, and this arrow here represents all my sensors, all my sales caches out there in my store, anything that's collecting data for me and send it through my pipeline. And the idea here is, perhaps I should have this arrow even larger, because the idea here is I'm pushing up a lot of data. I mean, gigabytes of data in an hour and things like that through this pipeline. And when this data needs to reach the storage place, the best idea, the implementation Lambda is you must have some service in between before it ends its final storage that can guarantee that you're not gonna lose any data if there are some instability in the channel. So the original idea here would be you get the data and you store in your SQL Server. But if your SQL Server goes down, if your SQL Server experiences some delay, something with the disk goes on, and you start getting overflowed with data, there is a great chance that you can start dropping packages, dropping data, and connections maybe not established in your database because your SQL Server is experiencing some sort of instability. So from the cloud platform, what we choose to do in here is we go into a service bus. You're going to go to some sort of service bus that can support the data that's coming in. So through that service bus that will be implemented here, we fork that data into two lanes. I think the name they use there is lane. We fork the data into two lanes. And the bottom line here for the lanes is this. If I want to keep things on a budget and still processing all the data, it's going to be hard to have something running the data real time. The gigabytes of data coming in every couple minutes real time. So what I got to do here is we create two lanes. We create one lane that will restore all the data that's coming in, and that's called the data sync or the batch lane. The book uses the batch lane terminology. I rather use the data sync because the idea here is the data is going through the pipeline, and they're going to, using big data terminology, right? They're going to sync that data in a storage somewhere. So I'm going to pick one of the Azure storage places that will just store the data to avoid any kind of delays, not going to process anything. It's just getting the data the way it is and store it somewhere. And the other lane is like, I'm going to get that data that's coming in the queue, through the queue, and I'm going to make sure that I'm not going to lose that data. So again, keeping it on the queue so I can replay the data if something goes bad in my processing time. And the next thing I'm going to do with it is processing it on a discretionary basis, meaning any data that's not really relevant to show on a dashboard, I'm going to just drop it. Because since it's irrelevant for the dashboard, I don't need to get it through. And if I don't get it through, my pipeline start becoming less pressured. I don't have that many data going through all the way to the end through the Power BI dashboard. So the discretionary thinking here, the discretionary processing here, it goes exactly like this. I get the data in, a sales came in. At this moment in my dashboard, I'm showing any sales that comes through. But let's say I want to be aware of any big sales record, sales transaction. Like imagine it's a credit card, and the credit card, the guy got a $8,000 transaction on the credit card. That could raise attention. Say, what's happening here? Why that big of a transaction? So any credit card transaction that's under, like say, $1,000, I don't have to show in my dashboard. But then things go over 1,000, and especially the 8,000 one I just mentioned, I want to show some title there to call people's attention. Say, look, this thing is happening. On a production line, for instance, the sensors are measuring temperature and all of that. And if a record comes through and the temperature is in the acceptable range, I'm going to drop that one because everything is fine and don't have to worry about alerting anybody. But if some temperature information comes in from the sensor, it's above the threshold, then I would get that information through the discretionary process to be served to Power BI, but it doesn't hit Power BI yet. On the other lane, on the batching process, what happens in here is data is being accumulated on the data sync, and not on real time like the view lane here is going through, discretionary lane is going through, but not in real time, but like on a schedule, like I said, 30 minutes a day, every 30 minutes, or every hour, whatever it's my time frame there. I will have a batch process that will go into the data sync and will process everything that's there in the data sync. So I want to have an average of the sales. So the average doesn't go through here because in order to calculate that average, I would have to keep memory, to do the average over time through the amount of sales that's coming through. That one doesn't have to be real-time dashboard. That one can be, time-lapsed information, and therefore I would have the batch process coming here into the data sync, processing the sales for that period, like 30 minutes, and getting that information processed and placed into another data storage for the batch processing for the view lane. So the implementation of LAMBDA, and by the way, LAMBDA, the idea of LAMBDA, let me go back here to the browser just quick. If you want to get why they call this LAMBDA, if you go Greek LAMBDA letter, that's the idea, right? You get one stream and you branch it in two. That's the whole idea of it. I'm a developer at heart, so LAMBDA in C#, it's like an anonymous function, a very neat way to do anonymous functioning there. It's about processing. But here is that idea you get one branch and you spread it into two. I found it confusing when I first heard about this because LAMBDA is such a wild card name. So many things are called LAMBDA, but that's the idea here. LAMBDA split one stream in two. And then when the data hits here in your database, in your SQL data storage here, from both the batch lane and the discretionary lane, what happens in here is this database is what makes the throttling in between your massive data ingestion and whatever is showing the data for the end user. So the whole idea of having these databases, these two databases in here, is to have Power BI or any other visualization to use, like Click or Tableau, whatever you are using, be able to support data coming on their terms. Like Power BI, for instance, it supports you sending a new feed every second. So that PowerShell query push I was doing there, I can ping information to Power BI every 1 second. I think I can send like a certain amount of pushes within the second, but some of them got dropped. I tried that in real time, real life, and I saw some of them being dropped. So if you do 1 second and you're in a safe place, for a friend's project, we decided to do every 2 seconds with some payload that can have up to some megabytes of data in every payload. And here's where the code that sends data to Power BI will happen. That PowerShell code, actually, we're going to do this in Azure Functions, like I said. We run every 2 seconds, get the latest from what came through the discretionary lane and whatever is served on the data service every 30 minutes on the examples I'm using here, and send them to Power BI. So that's the general idea of the LAMBDA architecture, and one way to implement LAMBDA architecture in Azure technologies, like I said, is using IoT Hub, if it's really for IoT, or the service bus, any other sort of service bus. We have many options in Azure for service bus. So if I go here to the portal.azure.com, if I go here to the portal, what happened here? Welcome, maybe later. Oh, Yoda doesn't have an account. Let me sign up from Yoda. And let me use another account here. Some little credit still there. Let me use, I was doing a presentation Monday in Sunnyvale for an audience there. And I created this account here, Sunnyvale at azuretraining.guru. I created this domain here just for fun. And my password there was this other one. Hey. So if I go here on, like, I have a storage in here, one of the ways to create service bus in storage in Azure is using a storage element, and I can use here queues. I can create storage queues. So depending on here's the thing, this is what I love about Azure. Depending on the amount of data I am going to travel in between the lanes, if the data that's coming from the IoT services, it's not as big as it, other scenarios could implement, I could use this one here. And this one, what are the limits of this one? That's the idea. When you get to choose which service you want to use, you got to choose it based on the specifications of the service and also on budget. Because for my clients and my friends' clients, budget is always a very important aspect of the solution. So how much am I going to pay for this? And Azure queues, blob queues, they are very, very inexpensive. But the thing is, the performance is not that good. So if I go Azure blob specs, I think. If I go to Azure blob storage specs, introduction, high performance, nope, not this one. Not pricing. Maybe this one. Nope, not this one. Should have it in my slides, right? I usually have a lot of time when I'm doing this on location at locations. So let me try this one here. Azure blob speed, scalability, performance. I think it's this one here. Perfect, found it. So if I go here to queue, Azure queues, and look at the elements in here, see, I got the size of my queue, so size is not that big of a problem, but this is the one, maximum request rate per storage account, and I got 20,000 per second. So if my demand fits in here, I can use this one here because this one is the less expensive one. It's very simple on what it can do. So on the Lambda architecture, when you go here into the storage, you have to do the storage yourself, but it's cheap. So for simple scenario, it's very, very cheap. So you can use the blob storage, or if that one doesn't fit you, so you can go here in Azure and you can go for the IoT Hub. There you go. So when you go to this guy here for the IoT, actually IoT Hub is the top of the line. If I get a service bus, there you go. Service bus is right in between, and then you get the IoT Hub there right after that. So in terms of pricing, you can go with this one. And if I really work with sensors with more demand, especially if they're using like a face recognition, image recognition, you go IoT Hub because it has a back channel for the blob information. So you get one of these guys here collecting the data from the sources. And then the next thing to do, because this is very inexpensive in Azure, is using Azure functions. Now, since we did this experiment about a year and a half ago, we've been through all these user groups like this one here, presented this to people, say if you want to really automate stuff based on events like event hubs in Azure, and they want to pay almost nothing, and in some cases really don't pay anything because there is a free threshold there before they start getting charged, Azure Functions is the way to go. And since this is cloud, it's not programming, I'm going to save you guys from seeing the C# code, which is kind of a very, very simple code. It's like no more than 20 lines. But in terms of SQL Server, if you're really going to use SQL Server as your storage for the sink, if your data fits in the sink, you can do your regular SQL Server approach. But the most important thing for the speed lane, because the speed lane is almost real time, the trick in there is to make sure you use memory optimized tables, in-memory tables. And I do have here a code to show you some of the examples that I have. Let me get this guy here. Come on. Bigger. It doesn't want to zoom in. So let's get this one on Notepad++, where I know I can zoom in just quick here. There we go. So the important thing here is two elements, right? One, the first, this is the regular tables. This is the one you don't want to use on the speed lane, and this is the one you want to use on the speed lane, right? With the memory optimization on. You want to create your table pretty much in the same way. There are some things you have to estimate for your table, like the bucket count to create the hash buckets for your table in memory. And the index also, you gotta have some bucket counts in there. It all depends on the amount of data that's coming through. And the key thing here, especially if you are using Azure SQL database, not the VM, but actually the actual SQL database, is when you do this, besides getting the information way faster into the table, because if you're not aware of, when you do memory optimized tables, the good thing about it is there is no contention. In SQL Server, on a regular disk table, when you write to a table, there is this lock that goes on, and to avoid data corruption, right? When it's a regular disk table, but when you do in-memory table optimized memory optimized tables, there is no lock, and the thing happens in memory. So that scales the throughput of that table, really, really high. The bottom line here in my test is when I compare a regular table load with like 500,000 rows and in-memory table with the same 500,000 rows, but the table with the same structure, I can get like 10, depending on the subscription, I can get like from 10 to 15 times faster on the memory table. So that's the big trick. And the memory table is not the only thing you got to do. You got to work two ways. You got to do the in-memory table, and you also have to do native stored procedures. So you got to do these two things, because you can do insert straight to the table, which is fine, but SQL Server has to create the query plan to get that information to our in-memory table. So creating the query plan takes time. Now, if you do the same insert, but you store that insert in a native store procedure, when you do that, SQL Server creates a machine code. It's like assembly code. You can see the C++ code that's created behind the scenes if you want to. But the point is there is no query plan to be evaluated. The code is already there, and it is going straight to the memory, to the table in memory. So if you have to use these two together, the native store procedure and the memory optimized table, in order to be able to create a fast enough throughput channel here, in order to do your discretionary processing, discarding the rows you don't need and keep the rows you need without creating some struggle here on this channel. So yeah, the demo here would be something in Azure, but I don't have the credits there to show you that. A more robust implementation here would be not using SQL Server altogether on the speed lane, but using some other data storage that would not create locks in the same way. And those usually are implemented in non-SQL storages like DocumentDB, and from Microsoft we have the Cosmos DB, which is, this thing is really, really fast. Any transaction sent to Cosmos DB is at least, at this lowest 1 digit milliseconds, never 2 digit milliseconds. So most of the time it is under 1 digit milliseconds. So up in the cloud, right? So which means that you can ingest data here really, really fast. The problem with Cosmos DB that most people find is it tends to be more expensive than a regular SQL Server database. So if you need to resort to this one here, you got to make sure to get it clear in your mind to understand how Azure charges you in terms of data utilization from Cosmos DB. But you definitely don't want to use your Cosmos DB in your batch lane, because when you read from the batch lane, you usually read a massive data amounts, and that's going to be very expensive in Cosmos DB. So when your demand goes higher, the idea here is you store into blob storages, regular blob storages, blob storage, because you're not going to change anything that's going into the blob. And when it's time for processing, you use some sort of a data warehouse solution like Azure SQL Data Warehouse or Snowflake, which is another vendor's data warehouse solution available in Azure, to process the data there, create your materialized views, and then serve Power BI with those materialized views. Yeah, so that's about it. That's how you create insights based on high throughput stream channels without losing your data, by using Azure functions, collecting the data and talking to either data layer you're going to use, some sort of a service bus implementation like IoT Hub and some other service buses in Azure, depending on the scalability you need, and SQL Server as an option on your discretionary processing on your speed lane in the LAMBDA architecture. So that's all. Do we have any questions?
Yeah, Armando, we do have one question here. In SSRS, the data source can be parameterized so that user can select a SQL Server and database at runtime on the dashboard. Can that be done in Power BI? So on the dashboard, you can select across multiple servers and databases.
Well, if you run, focus on the topic in here. If you want to have real-time data, Power BI is not going after the data. The data is coming into Power BI. So the question really doesn't apply to this scenario, because, like I said, Power BI is not collecting the data that is reaching to Power BI. On the other hand, in the regular Power BI utilization, if you're using Power BI on directing on imports, Power BI will query the data from the sources and cache the data within its own storage, meaning the parameters you use in SSRS to collect data from the sources will be just filters on your report, because you mirrored all the data you need inside Power BI. When you do direct query and you define filtering parameters in direct query, the direct query data connector support will send those parameters to the data source. So it's not like, bottom line is, it's not like SSRS where you have an empty report area, you parameterize the thing and then the report renders. It doesn't work like that. What happens is, as you interact with the reports in Power BI will either filter the data that's already in its analysis service storage, or will send queries every time you change some filtering parameters to the source and re-render the same report. So it's a similar behavior, but on the interface, nothing resembles it.
Right. Okay, great. That was the only question that we had at the moment. So I think with this, I'm going to wrap things up. Again, thank you, Armando, for presenting here today. This is a pretty great topic.
Thank you.
Cool. It's cool to see this stuff. I had done similar stuff prior to this all being available, and it was much more difficult, to say the least. And, a lot of effort just to get it to do even half of what you're able to do here in just a little, a few points and clicks. And so
Azure made it really easy for us.
Yeah, it's like a giant Lego box. You've got all the tools. Now you can build anything you want.
Yep. If I may add here just quick, there is a new player coming to this arena, which is Azure Databricks. So if you want to take a look a little further on this LAMBDA implementation, actually the product team, I was there at Ignite, I spoke with the guys there. The product team, they kind of suggest moving away, the product team for the Azure Databricks, moving away from the Lambda implementation, do what they call snapshots using Azure Databricks, and Azure Databricks is based on the Hadoop technology, and they said that that's the next big thing coming to big data processing and insights near real time. So here's the tip, right? I have not incorporated this into my presentation yet because I have not tried it yet, but here's a tip.
All right. Sounds great. All right. Well, thank you everyone for coming. If anyone is interested in presenting at some point in the future, we do have a pretty open calendar. We have another session coming up in 2 weeks. And then after that, we'll have sessions after the PASS Summit. So Armando, thank you again. And for everyone, have a great afternoon or morning or whatever part of the day that you're in. And talk to everyone next time.
Thank you. Thanks for having me. Have a good one.